Assalamualaikum and very good evening to audience. So today we here to present our assignment, which is pressure impact. So the presenter, of course, first is me, Muhammad SYAFIQ bin Abdul TALIB. Next.
It's me, Muhammad NAJMI bin Muhammad SABRI.
And me, FARIS bin EBRHIAM.
And me, Muhammad BADRIN bin SHAMSUHAIMI.
So today we here to present the pressure impact. So the objective of the experiment is to perform experimental and simulation flow exercise in hose pipe. Second is to analyze pressure variation in hose pipe over a specific pipe length with two different configuration. And third is to report the finding in an appropriate approach. So for the introduction, we know that pipe pressure impact is domestically used in fertigation. What is fertigation? Fertigation is technology that combines irrigation and fertilization. Fertigation technology use a pressure system of water. So when the fertilizer has been integrated into the irrigation of water, it then eventually, regularly and quantitatively water the growth and develop root zone of the crop through the pipeline and the dripper. This allow the root soil to remain loose and to maintain the appropriate water content. It also allow farmer to design the fertigation system according to the characteristic of different vegetable. Then fertilization cycle make the plant receive a proportional amount of water and nutrition regularly and quantitatively. So
next, for the experiment, the equipment that we must use, first is 3/5 mm diameter single connector, 16 mm T connector, 16 mm times 10 meter hose pipe, 5/10 mm measurement cup, hose clip and stopwatch. Okay, for the task 1, the experiment has been conducting to measure maximum flow rate V and velocity V1 from a hose pipe. Then continue to measure the maximum achievable water jet as shown in figure below. Maximum pressure in pipe has been calculated based on Bernoulli equation. Assume the system is frictionless. So the experiment is as shown. The time taken to fill in the cup is 13 seconds. For the step 2, the hose pipe has been setting up as shown. So I will share the experiment. Okay, can see or not?
yes.
For the first configuration, what we need is single connector to connect the pipe, hose clip to make sure no leaking, and make 5 holes at equal distance. That is 10 cm for the distance, and make sure the end of the pipe is blocked. After that, open, tap to maximum and measure the flow rate. For second configuration, we will use T connector to make it closed loop, and also use hose clip to make sure no leaking. After that, make 5 holes at equal distance, that is 10 cm, and another 5 holes at here. Finally, open the tap to maximum and measure the flow rate of the water.
But you have finished present?
Yes, already shown the video for step 3. Can proceed to
Okay,
next.
Nick, can you continue with the calculation?
Okay, for the calculation, we have 3 experiments. So we have calculation for experiment 1, experiment 2, and experiment 3. We got the result and data from the experiment that were conducted by MUHAMAD BADRIN. So this is the experiment 1 on the screen show. So after the calculation, we tabulate the result and the data. So next page.
Next slide, Aiman.
Next
Oh,
slide.
next slide. Oh, sorry. Okay.
So this is the data that we have collected from experiment 1, experiment 2, and experiment 3. So this is the result that we get. So continue, Aiman.
Okay. For the simulation result of the flow through pipe, we actually have to do 2 simulation. First simulation of flow through pipe and second simulation of 90-degree pipe. Okay, for the simulation result of flow through pipe, this is the geometry. This is the meshing. We can see the line on the sketching for meshing. Okay, this solution for the flow through pipe. We can see the graph for residuals. The color turquoise, purple, and green. Okay, for the result, the red color is the maximum velocity streamline, which is 3.77. The power of 6, and the minimum is 0.00, power of 0. Okay, for the second result, the simulation result of the 90-degree pipe, this is a geometry. You can see the shape is L, and the meshing, the shape changed to the black color. For the solution, we can see the graph inversely proportional, which is the purple color is the higher gradient, and the result, the maximum velocity streamline is 7.805, power of 0. Okay, this is the final result. We can see from the presentation the final. Okay, for the last task 5, discuss your findings regarding pressure and velocity over the different pipe configuration. Okay, from the discussion, we can conclude that the relationship between pressure and velocity is inversely proportional. When the velocity high speed, the pressure will decrease, and vice versa. This is called as Bernoulli principle. The diameter of pipe affects the pressure in the pipe. When the velocity will be higher, when the pipe is small. Length of the pipe also affect the pressure and velocity. When the length of the pipe increase, the pressure and velocity will decrease. Okay, last but not least, for the conclusion, Nick.
Okay, for the conclusion, in this experiment, we have conducted to measure the maximum flow in the pipe. When water flow through a pipe, there will be a pressure drop that occurs as a result of resistance to flow. With success to achieve the objective of the experiment, there may also be a pressure loss due change elevation between start and end of pipe. So that's all from me.
Aiman.
Okay, thank you. That's all from us. Bye.